Hello, welcome to the 2017 Scholarship Calculus walkthrough, and let's get into it. Question 1a. Determine all integers such that x squared take away y squared, x to the power 4 take away y squared equals 71. Show algebraically that you have found all of the solutions. So the key word in this question is integers. So firstly, they can be factorized into x squared take away y, and x squared plus y equals to 71. Then because 71 is a prime number, this this will be plus minus 71, and this will be plus minus 1, or vice versa. So x squared take away y is equal to 71. X squared plus y is equal to 1. 2x squared is equal to 72. X squared is equal to 36. X equals plus minus 6. Then I don't think it matters, so I don't think it's squared. So 6 squared take away y equals 71. What's 36 take away 71? Is that negative 35? Okay, yeah. Y equals to 35. Right. I don't know, y equals negative 35. I believe, yeah, so for this case there is x is equal to 6, negative 35, and negative 6, negative 35. Those are the two cases. For x squared take away y equals 71, x squared plus y is equal to 71. Can we just take x squared take away y equals negative 71, squared plus y equals to negative 1. Actually that creates imaginary solutions, but that is not it. So this is create solutions. Integers are real numbers, then x squared plus then can we will this change? So we just have x squared take away y, so x squared take away y equals 1, squared plus y equals to 30. No, not 31, equals 71. Actually 2x squared is equal to 36. I don't think this matters. Does it? Actually, this creates, x squared is equal to 36. X equals plus minus 6. yeah, actually this does matter, since then if we plug, so 6 squared plus y equals 71, y is equal to 35, so it's 6, 35, and negative 6, 35, and so yeah, these 4 are the solutions. These 4 are the integer solutions. The equation x squared take away bx over p take away y equals ax plus c over p plus 1 has 2 real roots of equal magnitude but opposite in sign. Prove that bc over a is less than 0. Question 1b. So we want to create just a polynomial. Not a polynomial. Just a normal equation. So ax plus c, p take away 1, px squared take away bpx plus x squared take away bx equals apx take away ax plus cp plus, oh no, take away c. Yeah, then we get this all to one side, px squared, 6 squared, take away bpx, take away bx, take away apx plus ax, take away cp plus c equals to 0. Then we can factor out x squared and x's, so a take away p take away b take away bp x take away cp plus c is equal to 0. So b squared, wait, okay, so because the opposite in, because so we let the roots be alpha and beta. So alpha yeah, so basically, since actually no, right, so because the roots are opposite signed but equal, alpha plus beta will be equal to 0, since they cancel out. And so and sum of roots is equal to negative b over a, minus a take away ap take away b take away bp over p plus 1 is equal to 0. Negative a plus ap plus b plus bp equal to 0. Actually, we can create an inequality so that the roots alpha times beta is less than 0. And wait, factor. Yeah, right. I think factor. Right. Um, right. So alpha times beta is less than 0. Right. Are they just minus CP plus C is less than 0? Oh wait, no, actually no, this is like the only constant, so we can just say C brackets P take away 1 all over P plus 1 is less than 0, since this is the equivalent to the roots. Okay, so from this equation we can pull out P brackets A plus B equals to A take away B. So P is equal to A plus B over A take away B. No. A plus B take away. A take away B over A plus B. So C brackets A take away B over A plus B take away 1 over A take away B over A plus B plus 1 is less than 0. Actually, was I able to just oh no. Then C brackets minus 1 minus A plus B, so it's 2B over A plus B over 2A over A plus B minus B. We can all you can multiply all this by all A plus B, so negative 2BC over 2A is less than 0. Cancels out, negative BC over A is... Oh wait, what did I do wrong? Huh? I can't, because they'll mean BC over A is greater than 0 if I multiply all by... Wait, yeah it does, so... Where did I go wrong? C brackets P take away 1. Right, oh no, right, the, right, sum of roots is equal to negative B over A, and product of roots is equal to C over A. It's minus C brackets. Right. Oh wait, no. Oh my no. Oh, I think this turns into minus. So that, yeah, because this turns into plus C brackets 1 minus P. Yeah. So this is actually 1 minus P. Negative. I think A plus C. So right, then let's just pause it to be then that's positive. So yeah, it is indeed this. Okay. Question 1C. X0, Y0 is a point on the parabola y squared equals 4ax and a is greater than 0. AC is the tangent to the parabola point A where C is on the x-axis. F is the focus of the parabola. B is on the point C 0, y0 on the xy axis. Angle BAF is from points y squared is equal to x. This is the focus, so point F is at A0. Yeah, that is at A0. A minus. Wait, this angle is theta, I think. Wait. Okay. Okay, so basically what we can do is actually let this angle be theta, then the angle xy0 is xy0 equal to theta. Okay, so because distance AF is equal to A take away x0 squared plus 0 take away y0 squared, square root of that, which turns into A take away x0 squared plus y squared, y0 squared, square root of that. Then okay, so we can get this point. So how can we get this? Okay, so we can get the derivative of here. So because y squared is equal to 4ax, 2y dy over dx is equal to 4a dy over dx is equal to a over 2a over y dy over dx at x0 y0 is equal to 2a over y0. Then y take away y1 is equal to m brackets x take away x1, y take actually no, we can't guess what that. Y take away y0 is equal to 2a over y brackets x take away x0. Hmm. Okay, so so the distance a, so the distance a if is equal to this. So I'm going to get this point and take this point away from it. So y take away y0, so x. So this point will be y will be 0, take away y0 is equal to 2a over y. Right. Okay, there's a y in the a in the function. X take away x0, negative y0 squared all over 2a is equal to x take away x0. So this x point is at x. This x point is at x0 take away y0 squared over 2a. Is that correct? This feels like a very awkward number to play with. So we want this. So this is at a 0. So a take away x0 take away y0 squared over 2a over this, right? They're both at 0. This should be the distance. Oh, I know. Huh. Actually, I probably want to turn everything into functions of x. This is getting a bit confusing. If so, y0 that y0 squared is equal to 4ax. So right, yeah. So that's a minus x all squared minus 4ax, which is 2 x squared take away 6. Oh, that's 0. That's 0. 6x0 plus a squared. Then okay, let's just turn this into 2a over square root of 2a square root of 4 is a x 0 is equal to a over square root of is this correct? It seems correct. Square a 0 x 0 actually is it right? No, that does not. That actually just doesn't translate. This 0 doesn't actually matter. Right, so gradient is equal to a for y, then so y is equal to square root for ax. Then so 2a over square root of 4ax 0. Actually, no, that's just half, so I think that just cancels out. H to the power of half over x 0 to the power of half. There's a gradient at x, there's a gradient here. So y, take away y 0 is equal to a half. Actually, no, that could just factorize all that. Square root of a over x 0. Brackets x, take away x 0. Then we know that this point, so that negative y 0 is equal to square root of a over x. X take away x 0. So I probably want this is I take away square root of x. Square root of a over x. Alright then x take away x 0. And that's 2x. That's I think yeah that's 0. Alright, this very nicely cancels out, I think. Right, that's no yes the a's cancel out, then you get 2x 0 is equal to x 0 negative x 0. So this is negative x 0. This is a, so distance will be a, take away negative x 0, I believe. No, this doesn't sit right. Oh wait, oh wait, oh no, oh wait. This is supposed to be plus. So this is you check x0 x take. Oh wait, actually, I know it's plus. So x plus a square with that, which is equal to x0 plus a, which okay. So we just proved that. Therefore, if c is equal to a, if so, let me just draw this. Draw a curve. Okay, no, this doesn't work. So let me just. So because this distance and this distance are equal. So okay, so basically we let this equal to theta. So therefore this is equal to theta. But so this is 180 take away theta. But then so these two so angles ACF and angle ACF and angle CAF add up to theta. But then because triangle AFC is a isosceles, the angles will be equal. So therefore angle a CAF is equal to theta. Therefore AC by E6 BAF. Okay, question 1 done. Question 2. ABCD is a rectangle with AB equals 3 square with 3 units. AD is equal to 3 units. PQRS is a quadrilateral with BRQ and AQR. And BRQ is equal to C. Oh no. This is equal to this. C is equal to DSP. Okay, C is PD is equal to APQ. This okay, so these two are equal. So this is what is essentially okay, I'm gonna let this angle be alpha, beta, gamma, and delta. So with that not oops, I rubbed out a beta. this, oh no, this is beta. So this angle will be 180 minus beta. This will be beta alpha. Alright, so we alpha plus beta is equal to 90 degrees, because here and here, and this is the right angle. This is 180 minus 2. This is 180 minus 2 beta. 180 minus 2 delta, and 180 minus 2 gamma. So essentially 4 times 180 take away 2 alpha plus beta plus gamma plus delta. This is equal to 360. 4 times 180 is 720, I think. Yeah. So negative 2 alpha plus beta plus gamma plus delta is equal to negative 360. Alpha plus beta plus gamma plus delta is equal to 180. Alpha plus beta plus we know that alpha. Actually, no, we'll get back to the start. My right. SPQ. Actually, oh wait, I didn't read the full question. AP is equal to X and APQ is equal to theta. This is theta. So 180 to AP. APQ is equal to theta. This is theta. That's these these are equal, so 90, oh no, 180 take, oh wait, yeah, these are 90 take away, right, oh yeah, that, so 80 take away theta is equal to 2 angle of APQ, so angle of APQ is equal to 90 take away theta over 2. This is 90 take away theta over 2. This is also 90 take away theta over 2. plus 90 take away theta over 2 plus angle AQP is equal to 180, 90, 90. Alright, 90 plus 90, these two cancels out. So angle AQP is equal to theta over 2. Over 2 theta over 2. Likewise, 90 plus 2 plus angle QRB is equal to 180, cancels. So QRB is equal to 90 take away theta over 2. Here is 90 take away theta over 2. Alright, this is also theta over 2. So this is also theta over 2. So right, I think this creates a parallelogram. This creates a parallelogram, so these two angles are theta. These two angles are 180 take away theta and 180 take away theta. So, right, the question is, show that the pyramid of PQR is so, this is theta over 2. Sine theta over 2 is equal to opposite over edge over hypotenuse. So x over PQ. Oh, by the way, this does mean that actually this is not a parallelogram. This is what you call it, kite, I think. Right? Is it? Oh no, it's a parallelogram. So this and this will be equal this, and this will be equal. So sine theta over 2 is equal to PQ. PQ is equal to x over sine theta over 2. Then this is x. So this distance will also be x, I believe. Right. Right. No. AP is equal to x, so. Right. Oh no, wait. Will DP also be x? Oh. Wait. Oh, wait. No. Wait. Oh. Wait. Oh, no. It says angle APQ is theta. So here is 90 take away theta. So here is theta. Just rub a decent amount of these off. 90 take away theta. 180 take away theta. 90 take away theta. This is so 90 take away theta. Theta 90 minus theta. X. Wait, I think this distance is also x. So sine theta is equal to no. Cosine theta is equal to adjacent over hypotenuse. So x over p q. So pq is equal to x over cosine theta. Actually, no, we don't. Actually, this triangle DP can also be a similar triangle. I think. Hey, how? X. Did I missed anything again? Oh, I missed that AD is equal to 3 units. This is 3 minus x. So this, but we know that this and this are equal, so distance is, so wait, 3 minus p cosine theta is equal to 3 minus x over sp. Sp is equal to 3 minus x over cosine theta. So perimeter is equal to 2sp plus 2pq. So 6 minus 2x cosine theta plus 2x over cosine theta is equal to perimeter. So 6 over cosine theta equal to perimeter, I believe. Yeah, therefore isn't dependent on x. Show that the perimeter of PQS is, if theta is equal to radians, if theta is pi over 3 radians, x equals 2. So let me just, not enough space. So here, right, yeah, this will be 2, 1, then so 2, 1, wait, P A theta cosine theta. Yeah, I think this is also x, and this is 3 minus x. So 2, 1, 2, 1. Then this is pi over 3. So which is 30. Wait, no, that's 60. we can just 10 theta is equal to opposite over adjacent, so 2 over 10 theta is equal to, oh no, so to get this distance AQ, 10 is equal to AQ over 2, which is x, so 210 pi over 3, so this distance is 2 square. So let me just remove this real quick. So here's pi over 3 to 2 square root of 3. Then the distance of here is, yeah, square root of 3. Square root of 3 to, right, is that 2? Pi over 3, this is pi over 6. So this is over 6, right? 10 square root of 3, 10 pi over 6. Oh no, this is equal to 1. Alright, what was the question again? PR. We can, actually we could just, so 2 square root of 3, this is square root of 3. This is pi over 6. So cosine pi over 6 is equal to adjacent of square root of 3 over QR, I think. Cosine theta is equal to adjacent over hypotenuse, so QR is equal to square root of 3 over cosine pi over 6. Which is equal to 2. Then we get, so we want to get distance. So this is pi over 6, so this is pi take away pi over 3, which is equal to 2 pi over 3. So, and then cosine rule is a squared equals b plus c squared take away 2bc cosine a. So, wait, no, we need to get distance. PQ squared is equal to 2 squared plus 2 squared root of 3 all squared. 4 plus 2 square root of 3 all squared. Oh, no, alright, so PQ is equal to 4. So a squared is equal to 4 squared plus 2 squared. Take away 2, 4 times 2 times 4 times 2. Cosine 2 pi over 3. Let's just square root that. 4 squared plus 2 squared, right, plus 2 squared. 2 times 4 times 2 cosine 2 pi over 3, which is equal to, oh no, I did put divided by, which is equal to 2 square root of 7, I believe. Solve the algebraically, so algebraically the systems of equations. x plus y take away z is equal to 1. Squared plus y squared take away z squared is equal to x cubed take away z is equal to 43 take away 3xy. So this is equation 1, this is equation 2, this is equation 3. We can rearrange that to equation 1 to x plus y equals 1 plus z. We can square both sides, so x plus y squared is equal to 1 plus z all squared. X squared plus y squared, yeah, we can, wait, 2x, no, there's 2xy here. So x squared plus y squared plus 2xy plus z squared, no, take away z squared. Take away z squared is equal to 5. 1 plus z all squared take away z squared is equal to 5. 2z plus 1 is equal to 5. Z is equal to 2. Did I miss other plus or minus sign somewhere? Does not seem like it. So, and then x plus y all cubed. This is equal to x cubed plus y plus 3xy x plus y, I think. Yeah, this is common. This is kind of common knowledge, I think. Actually, let me just substitute it. X cubed plus y cubed take away 3xy take away 2 cubed is equal to 43. X cubed plus y cubed take away 3. So y is equal to 35. Right. No, we can also get x plus y is equal to 3 from this equation, from equation 1. Actually, can I just... Right, let me just rearrange that. Yeah, I can rearrange that to 3x cubed plus y cubed is equal to 35 plus 3xy. Then I can add x cubed plus y cubed plus 3xy x plus y to both sides. So x plus y all cubed is equal to 35 plus 3y. This is equal to 3. 35 plus 9xy. X plus y. Yeah, this is equal to 3. So 27 is equal to 35 plus 12xy. Does this seem correct? Wait, this does not. Wait, this. I'm not sure if this is correct. X cubed take away. Is this correct? Wait, no, this is minus. This is minus. Wait, did I keep the? Oh no. It's 6. This is supposed to be minus. Oh no, this is not supposed to be. This is supposed to be 6. 6xy. Nah, this still feels like an awkward number to play with. X cubed plus 3xy. Let's see both sides. So we got x plus y minus 3xy. X plus y is equal to 3, right? Then x plus, we got x plus y is equal to 3. X plus y cubed. Seven is equal to 35 plus 6xy. So I don't know. When I did this, yeah, it did not give me this number. X cubed plus y cubed take away 3xy is equal to 30. Yeah, that should be true. Plus 6 equals 35xy. So we better x cubed plus 35 take away 3xy. X plus y is equal to 3, yeah. Take away 3. See, I'm already now into question 2. Oh, this is going to be a pain. Huh? X plus y take away z is equal to 1. Right, let me just... X plus y all squared is... z equals to 2. Let me just write everything up. X plus y is equal to 3. Then it's cubed plus cubed. Oh wait, no, wait. Oh wait, no. Oh, this is 51. This makes more sense. This feels like a way better number now. Okay, yeah. This seems like something I got when I did it like 3 months ago. XY is equal to -4. What was that? Wait, how do I do this now? Wait, was it just x squared? Oh no. X equals -4 over y. So x plus so y take away 4 over y is equal to 3. Y squared take away 3y take away 4 equals to 0. Y equals 4 -1. And y equals 4 creates x equals -1, y equals negative creates x is 4, so 4 -1 and -1 4 are the two solutions, I believe. Right, is it possible to create? I don't think it's possible to create any other solutions. Yeah. Right, no, so 4 -1 2 and wait, actually no, they're supposed to, wait, this is cubic. Are there supposed to be 3 solutions? There might be 3 solutions instead of 2 since it's a cubic. And actually no, okay. Actually no, there shouldn't be. Okay, no, there should be. Just test this out on my calculator. Net x equal to 4. Oh no. 4 to x -1 -1 to y 2 to z x plus y take away z equals 1 x squared plus y squared take away z squared equals, what's 5 take away 2 xy, that's 13 x cubed plus y cubed take away z cubed 43 take away 3x y. Okay, yeah, that's good. Okay, for y equals x power of x1 dy over dx where x equals 2, you may use any valid algebraic techniques such as implicit differentiation and or logarithm. So y equals x to the power of x to the power of x. Let's take the natural log of it. We bring those two down here. Yeah, I think we take the natural log again. Natural log of y. Then natural log of x to the power of x times natural log of x. I think we break this up into natural log of x over x plus natural log of x, natural log of y. So x natural log of x plus natural log of x is equal to natural log of y. I think we differentiate this, then we differentiate. So when we differentiate this, then we have to differentiate the thing in the function, then we have to differentiate the thing in the function again. So 1 over y times 1 over natural log of y times times y, I think. Wait, is that true? Oh no, wait, no, times dy over dx. Oh no, I'm correct. Since we did, so a dash b, which is f dash g, which is natural log of x plus g dash f, which is 1 over x times x, so that's just 1 times 1 over x. Derivative of that. So dy over dx is equal to y times natural log of y times natural log of x plus 1 over x. Instead of rearranging to find natural log of y, we can just y equals x to the power x. So y is equal to 2 squared, which is equal to 16. So 16 times natural log of 16 times natural log of 2 plus 1 over 2, which is equal to 2 plus 1 plus. Is that correct? I don't think that's correct. No, it's like, that doesn't seem right. It doesn't sit right with me. If dash g, which 1 times natural log of 1 with natural log of x, and g dash f, so that should just stick to 1, then plus 1 over x, natural log of natural log of y, so 1 over natural log natural log 2 plus 1 plus natural log 1 plus. Oh wait, oh no, natural log of x. So we derive this, the inside function, which is 1 over x, then multiply by the derivative of this, so 1 over x, so 1 over natural log of 2, which, okay, that seems like much better. Let me just test it out on the calculator. X to the power of x to the power of x at 2, indeed is this, so plus half times natural log of 2, which is equal to 107.11. Okay, let y equals 8 of x sine x. So dy y over dx is equal to f dash g, so of x, f dash x plus e to the power of x cosine x. So we can factorize e to the power of x out. X sine x plus cosine x. We can get cosine x into. Right, was this sine x take away? Sine, no, take away most of it, right? So x plus pi over 2. So sine x plus pi over 2 into the power of x, all of that. Then from the sheet time, this can be rewritten as sine x e to the power of x sine x plus sine, yeah, okay, so 2 sine 2x plus pi over 2 cosine pi over 4. Cosine pi over 4, I'm pretty sure is yeah. E to the power of x 2 sine x plus pi over 4 times square root of 2 over 2. So cancels out. So 2 to the power of half e to the power of x sine x plus pi over 4. D squared y. It might actually be easier just to just to derive this again. So let's derive this again. So which is e to the power of x sine x plus e to the power of x cosine x. Then let's derive this plus e to the power of x take away e to yeah, that turns into cancels out 2 e to the power of x cosine x. Then I think we can just turn it back into sine 2 e to the power of x sine pi plus sine, what do you mean pi? X plus pi over 2. Let's derive this again. So yeah. So dy over d this is equal to e to the x sine x plus e to the x cosine x. D squared y over dx squared is equal to 2 e to the power of x cosine x. D cubed y over dx cubed is equal to a dash b to the power of x dash b x sine x. Right. So this is e to x sine x. Right, so this is just 1. This is 2. This is 2. D4 dx4, which is equal to 2e to the power of x x to e to the power of x sine x, then derive this, take away 2 x x, oh no, this is, I mean cosine x, cancels out, which is equal to 4 e to x sine x, which turns into minus, which turns into 0 actually. Right, I can't seem to find a pattern here. Because I can't seem to find sine x plus e to the power of x. Actually, can I factorize this? Right, cosine x minus sine x, so right, I go x plus 2 x, which is equal to 2. Oh wait, this seems to be creating a pattern here. Oh wait. Is it 3 over 2? Right, this is square root of 2. No, this is cosine pi over 4. No, this is square root 2 over 2. Oh, yeah, then that's, then that oh I know, that it's just this that cancels out, so 2. It would be so nice if I just, this just turns into 3 to 3 pi over 4. This just turns into sine x plus pi over 4 again. Wait, oh no, actually no. So just 2. Oh no, wait, no. What does, wait, does it just keep on alternating between pi? No, it actually increases. X plus pi over 4. Let's see the time. guess we're going at moderate speed because we're going with derivative of 2e to the power. Oh wait, yeah, no, 2e to the power sine x plus pi over 2 take 2e to take away sine x. Right, surely it turns into 3 pi over 4 because this turns, because here to here is, surely it's like 2 to the power of n over 2 sine brackets in pi over, surely it's something like this. I mean sine x plus n pi over 4. No, let me just look at the math formula sheet. So sine, yeah, so we add to each x cosine x to e to the power of x cosine x take away 2x just equal to e to the power of x brackets x plus take away sine x. No, I'm just gonna assume that this is. I'm just gonna assume this because this seems more. This seems like the most likely. E to the power of n over 2. So at x equals 0, the x just turns into 0, so n pi over 4. So yeah, if actually no, this is just the function. Right, this is just right. Why does it? No, because 4 e to the power of sine x is. Yeah, 4 e to the power of sine x is just sine x plus pi in disguise, but this actually doesn't exist. What? Actually no. Actually no, this turns into. Huh. Actually, this will alternate between negative side. I might need to do something again. Since you're saying x plus n pi, since it'll go like here, so n pi. Actually, no, this is literally just a function. What am I talking about? Okay, I'm just gonna end it there. The hyperbolic functions sin x and cos x are defined by as follows. So let 3c y equals sin x, so inverse. Oh no, relate x equals sin y. Inverse sin x is equal to y. Then okay, for x to sin function y, we differentiate it in relations with y, so dx over dy is equal to cos y, but then let me just flip it, so to get dy over dx, so dy over dx is equal to over cos y. I think this is like a known identity. Cos squared y take away sin squared y is equal to 1. I'm not sure if this is actually legal though, because this is an identity that is sin squared y. Cos y is equal to 1 plus sin squared y squared. So dy over dx over square root of sin squared y. But then we what was sin y equal to x, so x equals sin squared y. So dy over dx is equal to square root of 1 plus x squared. Okay. I'll prove the integral of 10x. Integral of 10x 10 to x 10 3x x is equal to that. I think you can just derive the right hand side and rearrange for this. I think that is actually legal. But, wait, let me get my formula sheet out. Then I think we can use the compound angle 10x plus 2x is equal to 10x plus 10 2x all over 1 minus 10x 2x. Remember, this is actually still just 10 3x. So we multiply this to here, so 10 3x minus 10x 10 2x 10 3x is equal to 10x plus 10x. Then we can rearrange, so minus 10x minus 10 2x plus 10 3x is equal to 10x 10 2x 10 3x. We can integrate this, so integral of negative 10x is 10 2x plus 10 3x dx. Minus sine x over cosine x is sine x sine 2x over cosine 2x sine 2x over cosine 2x. So we let u equal to cosine x, and du over negative sine x is equal to dx. So and then we can do that likewise with everything. So u equals cos 2x u over negative 2 cos 2x equals to dx. U equals to cosine 3x u equals negative 3 cosine 3x dx. So 1 over u, take away half u, plus half u, take away 1 over 3u du into all of that. You go natural log of absolute value of u plus half natural log absolute value of u. Take away 1 over 3 natural log of absolute value of u plus c, which is equal to natural log of cosine x plus natural log of absolute value of half natural log of absolute value of cosine 2x, take away 1 over 3 natural log of absolute value of cosine 3x plus c. The length of a curve length of a curve is expressed in polar coordinates is given by so if we zoom in really closely into here, this starts at 0, which is like the angle from there. So 0 and so in between. So then I think it goes from here to here. So we just say, so we have half of this. So so this square root is just actually only gives us this half. So you can actually, I think we can just integral from pi to 0 of square root of r squared plus d theta o squared d theta. So we're integrating in relations with theta. So we can do d over d theta in this equation by so a sine theta, since a is a constant. So we square this, so we get a squared sine squared theta. So and then we r squared is equal to a squared take away 2a cosine theta plus sine plus a squared sine, oh no, a squared cosine squared theta. So a squared with 2a cosine theta, so a squared sine with theta. Okay. Actually, can I? Can I? Square 2a cosine theta plus a squared sine squared theta plus squared cosine squared theta. I think I am correct here. Wait. Oh wait. Oh no. Wait. A take. Yeah, no. It's supposed to be squared here. So we can factor out the square root of that d theta. We can actually factor out a here because we can factor out a squared from above. So a brackets 1 take away 2 sine theta plus can I use one of the half? Sure, I can use one of half angle this can be considered as 1. So 1, no, this 2 cosine theta. Wait, where's half angle? 2 cosine theta. I got 4 cosines. Alright, yeah, so cosine theta can be rearranged as oops. Yeah, cosine theta can be rearranged as 2 cosine squared theta with 2 take away 1. So, and then we have 2 of those, so a square root of take away 4 cosine squared theta over 2 take away 2 cancels d theta. Oh wait, integral of from pi to 0. Wait, 2 of them. Actually, no, we can also take this out as a constant. So wait, oh, wait, what? No, I got square root of negative. No, this is not allowed. This is not allowed. Square root of 1 take away 2 cosine theta plus sine squared theta. To a squared a squared take away 2a squared cosine theta plus it's r squared, then just dr over d theta. Wait, actually, can I use that? 1 take away cosine theta. Wait, let me just see that. 1 take away sine squared. 1 take away cosine squared theta. 1 take. To take. It's just can just 1 take away cosine theta. Square root of that. Then oh wait, I could break it into what can we, which half angle can we break cosine theta into? This does not seem right, but I might just try it out. Well, minus cosine squared theta minus squared theta. No, 1 minus plus sine squared theta. Then we wait, then wait. Oh no, wait, there's a half angle. Right. Yeah, that's a half angle. So over 2 theta over 2. Then 2. Then we can put this one into sine squared theta over 2 plus cosine squared theta to take away cosine squared theta over 2 plus sine squared theta 2, so 2 brackets 2, so yeah, square root of that, integral from pi to 0 to there's a alpha here, the 2 here, so 2 sine squared theta over 2 square root of that, and then we differentiate this with relations with theta, so 4a integral from pi to 0 of sine theta over 2 d theta, then 4a cosine theta over negative 2 cosine theta over 2 from pi to 0. Cosine pi over 2 is just 0, so right, so 4a 0 take away negative 2, which is equal to 8a. According to Newton's law of cooling, Newton's law of cooling, the gravitational force for an object of F can be replaced by ma. Surely we can just see, so mass acceleration is negative mass gravity r squared all over x all squared. You can just cancel m out from that. Acceleration is also equivalent to dv over dt, change in velocity over change in time, so get a g r squared all over plus r o squared. Is it dv over d? dv over dt is equal to dv over dx times dx over dt. Change in so dv over dx. So dv over dt is just change in your dv over dt is change in velocity over time, which is the acceleration, and dx over dt is change in displacement space over time, which is the velocity. So dv over dx times velocity is equal to the minus g of r squared over x plus. Oh wait, this nicely. We can just put this on here. So velocity of dv is equal to g r squared over x plus r o squared dx. Integrate both sides in relations with each other. So half velocity squared is equal to here's the x. I think we can just reverse chain rule it. So gr squared over x plus r plus c. And the velocity is 0. The velocity is 0. So right, they just cancel each other out there. It's supposed to happen. Yeah, they should just cancel each other out. Oh wait, no, never mind, they don't. So minus g squared over is equal to c, then instantaneously when velocity is the rocket is fired vertically upward with initial velocity of v and the hp. So this instance the height is h. So half velocity squared is equal to gr squared over x plus r. Take away gr squared over h plus r. We can multiply both sides out. Squared h gr squared plus r over plus plus let me expand this out. Wait, which the g h r cubes cancels out. Right, take away squared x, take away r cubed over x plus h plus r. Half velocity squared. These two cancels out. Squared x, right. Which is equal to g then this is equal to half velocity squared is equal to gr over h minus x over x plus r plus h. So we take the square root. So wait, V0 isn't V0 is equal to wait. Right, so V0 is where x is 0, so V0 is equal to where x is equal to 0. So V0 is equal to 2g squared brackets h. It's r brackets r. So h square root of that cancels. Just equal to 2gr h over r h square root of that. Okay. That was extremely boxed. Okay, we're not at too bad of a pace. Question 5. These are very close questions. Cosine 5 theta is equal to I theta to power okay. So basically we get each I theta to power 5. We get each 5 I theta. So cosine 5 theta plus I sine 5 theta is equal to cosine theta I sine theta all power 5. This gives Pascal's triangle. So that is Pascal's triangle at the 5th rank. So cosine to power 5 theta I sine theta cosine to power 4 theta, take away sine squared theta cosine cubed theta, take away I sine cubed theta cosine squared theta plus sine to power 4 theta cosine theta plus I sine to power 5 theta. That's equal to cosine 5 theta plus I sine 5 theta. So let's pair the real parts with real parts. So cosine 5 theta with cosine to the power 5 theta, take away sine squared cosine to cube theta plus sine to the power 4 theta cosine theta. So cosine to the power 5 theta, cosine to the power 5 minus sine squared theta cosine cube theta sine to the power 4 theta cosine theta. So cosine to the power 4 theta, take away 1 is cosine squared theta cosine cubed theta plus cosine squared minus squared cosine theta. So cosine minus cosine cubed theta plus cosine phi theta. Oh wait, no, for the constants, right? 5, 10, 10, 5 is a 5, 10 plus 10, 5 cosine theta, 5 cos, take away cosine cubed theta plus 5 cosine 5 theta, which is equal to 16 cos 5 theta. So minus 10 minus 10, so minus 20 cosine cubed theta plus 5 cosine theta. Phew. Find a polynomial in terms of cosine theta with roots cosine 2 pi, cosine 4 pi, and cosine 8 pi first. Find the general solutions for 5 theta. Cosine 5 theta equals cosine 5 theta is equal to cosine 4 theta. 5 theta is equal to is the general solutions here. 2 in pi 2 in pi, wait, was it minus plus or plus? Oh, it doesn't really matter. It's minus 4 theta. So theta is equal to 2 in pi. Oh, actually, no. There's also a possibility where 9 theta is equal to. Wait, theta is equal to k pi over 9. This is also a possibility. Alright, so that means so what we're trying to do is cosine 5 theta minus wait, how's this hint going to help? I might just as well do it anyway. Yeah, actually I think this is how I did it. 1 1 1 2 1 1 3 3 1 1 4 6 4 1. So cosine powering it by 4, so cosine to the power 4 theta plus I sine theta cosine cubed theta minus cosine squared theta sine squared theta minus I cosine theta sine cubed theta plus sine to the power 4 theta. Wait, is that 4? Okay, that is 4. So 1 plus, I mean, this doesn't matter, this is imaginary. 1 minus 6 minus, no, this is imaginary, so it doesn't matter again. So cosine 4 theta is equal to cosine to the power 4 theta minus 6 cosine squared theta plus sine to the power 4 theta. So this is 6 cosine squared theta because 1 minus cosine squared theta plus minus cosine theta all squared. Cosine for theta. So that's for theta. This 6 cosine cubed theta plus 6 cosine theta plus 1. Oh, this feels a bit awkward. Take away 2 cosine squared theta plus cosine 4 theta. So it cancels out, cancels out, cancels out. 8 cosine theta and 6 cosine cubed theta. Take away 2 cosine squared theta plus 1. Is that it? Right. Oh, wait. No. This is supposed to be squared. So that's minus. This should be squared. So this should be just minus 8, right? Sine squared. Right, that's yeah. Minus 8 cosine squared theta. It's 1. So sine 5 theta take away cosine 5 theta, cosine 4 theta is equal to 10 cosine 5 theta minus 8 cosine to the power 4 theta minus 20 cosine cubed theta plus 16 cosine squared theta plus 5 cosine theta plus 1 is equal to 0. This is true, so I'm hoping so. Then wait. Where did this plus 16 come from? This is plus. Wait, no. Yeah, because we're minusing it. No. There should be minus then. So what should I do now? So actually, yeah, I think we just find solutions from here. So we want solutions between 0 and x and pi. So let's use theta is equal to 2k pi. So yeah, the general solutions where I think this is true. Hopefully. So wait, 0 to pi over 9, 4 pi over 9, 6 pi over 9, and 8 pi over 9 are the 5 solutions, I believe. And how many with the weights cosine, does it specifically need to be in these 3? Surely we can just, actually no, we've gotten cosine 2 pi, cosine 4 pi, cosine 6 pi, cosine 8 pi, wait, cosine 0 is 1. This is special triangle, I think. Right, cosine 2 pi. Yeah, this is a straight special triangle with negative half. So alright, so basically theta is equal to 1 or negative half. So cosine theta take away 1 equals 0, and not theta. Theta isn't equal to 1. Cosine theta take away 1, and cos theta is equal to negative. Yes, 2 cosine theta plus 1 is equal to 0. These are the two roots. Two cosine theta plus 1 and cosine theta minus 1, which is equal to 2 cosine squared theta minus cosine theta minus 1. Then right, if we multiply this out by so we want to multiply this out by another cosine cubed theta plus b cosine squared theta plus c cosine theta plus d. I don't want to expand this out. Do I have to? Actually, no, we can quite clearly see that. Connect this with this. So, and the d with this. So d equals 1 and d equals 1. Then okay, wait, let me just try to shortcut this. So negative cos, so we want right. Um, right. Alright, we can. Right, okay, I'll just expand this out. So this is 8, and this is, I've got 1. So 16 cosine cubed cosine 5 theta plus 2b about 4 theta. Right, actually, I could just try to connect the key parts. 2b cosine squared theta. Then here and here, okay. When this by this creates this a minus 8 cosine about 4 theta, and we need cosine, and no other multiplications can create cosine to about 4 theta. And we want cosine to about 4 theta's coefficient to be a negative 8, so b equals 0. So this is actually irrelevant. So we can just pair up the. So 2 cosine squared 2c here and here 2c cosine cubed theta. What? Where else? Okay, actually no. Minus 16 cosine minus no, not 16, minus 8. 8 cosine cubed theta. What, how else can we create 2 cosine? Wait, 2c cosine cubed theta. Yeah, then minus cosine theta. This is b equals 0, so we can't get. Is this? I think this is just it. Is equal to. What is cosine cubed theta? 20 cosine theta, so 2c minus 8 equals 20. C is equal to 14, I believe. Right, 2c minus 8 cosine cubed. No, this is minus 20. Minus 20 minus. Oh no, this no, minus 6. So 2 cosine 2 cosine squared, take away cosine theta, take away 1, 8 cosine cubed theta plus b is 0, take away 6 sine theta plus 1 is equal to 0. Okay. This last question, I believe. Let's see if I haven't missed anything unlike last time. Okay, this is fine. Copium. Okay, another cursed question. I'm not sure if this is actually. I think you can just brute force it and still get 4 marks with it. Like I'm pretty sure a decent amount. If there's like algebra or like sequence, you can just brute force it and say there's a pattern between here and say therefore this is the pattern for the nth term. So first sequence is 2, 7, then second sequence is half 2 plus 7. Which is equal to 4.5, then half 4.57, which is equal to this 11.5 over 2, which is equal to 6.25. Yeah, I'm pretty sure it just keeps alternating between up. And then, right, let me just rub these out. So then, like 4.5 plus 25 over 2, which is equal 5 divided by 2. Yeah, 7.5. So this is 5 2 point plus 5 minus 2.5 plus 1 point. Wait, I did something wrong. I think this might be 6.75. Yeah, alright, no, that's 5 points. Minus 2.5. Yeah, I did. 5.75 divided by 2. 5.125. Let's get rid of this 5. Then this is right, 5.125, which is equal to 0.625 minus. So it just keeps on going down by half. So I think it's negative half to the power of n. I think. Oh wait. Then t1 plus t1 equals 2 plus t2. So I think we can just 5 because negative half to the power of n. That's then can say this. Wait, let me just see the middle market speed drum, sorry. Okay, so 5 negative half to the power of n. I think it's 2. So basically we can just add the constant, which is negative half to the power of n all over. Because 2 plus, yeah, always adding that. No, but we want the first term to be 0. We want the first term to be 0, so we want the first term to be 0, so 2 plus 5, right? I think it's 5 brackets 1, take away half, take away 1, then that creates 0, then that 2 plus then 5, then 5, then 2.5 with wait, well then that one take away half to the power of 3, 7 over 8. Wait, will that work? Wait, let me just check the marking schedule. 18 plus 1 take away 18. 18 is equal to 8 half. What right, so term 2, so the second term is equal to the first term plus the difference in the first term. Then the third term is equal to the difference in the second. Difference in the second plus difference plus the first term. But this first term we can just put this back in here, so term 3 is equal to difference in the term plus difference in the first term plus 2. So, and then for example, term 4 is equal to difference in the third term plus different term in the third. Then we can just replace this for here. So the fourth term is equal to difference in the third plus difference in the second plus difference in the first plus 2 plus plus 2, which is the first term. So we get the nth term is equal to the first term plus the sum of, wait, where is it? Let me get, yeah, the sum of the difference in terms. So t in, and then this sum can be is a geometric series. So and then which is equal to S in is equal to t in brackets 1 take away y r to the power of n all over 1 take away r. This is what essentially happens. So t in is equal to 2 plus so t1 is equal to, wait, the first term in the difference is 5, so it's 5 brackets 1 take away r, which is the rate, which is half to the power of n take away 1, which 1 take away r, 1 take away, alright, 1 take away negative half, yeah, 1 take away y, which is also negative half, so just 2 plus 5 brackets take away half, negative half, take away 1 all over 1.5. So this is how you get it. This is quite bulked in my opinion. I can't. Let's maybe just clean that out together. So 2 plus 10 over 3 take away half to the power of n take away 1. So as n approaches infinity, so half n take away 1, this just converges into 0, so it turns into 2 plus 10 over 3, which is equal to 16 over 3. That is the 2017 speedrun done. I believe, not speedrun, walkthrough. Yeah, I'm just triple checking if I missed any questions. No, I have not. Okay, thank you for watching.